Okay, let's look at solving inequalities. One of the applications of continuity is solving inequalities. All right, so let's go dive right into examples. All right, first example. We want to solve x squared minus 2x minus 8 is strictly greater than 0 for x. All right. So first thing we do is I'm going to rewrite it as an equality. So I write it as x squared minus 2x minus 8 is equal to 0. Since equalities is much easier to deal with than inequalities. Alright, so let's solve this first. So this is going by factoring out. So this is going to be quantity x plus 2 times quantity x minus 4, right, is equal to 0, right? So let's make sure 2 times negative 4 gives you negative 8. Positive 2 plus negative 4 gives you negative 2. So it seems like it's working out. So the equality gives you a couple of solutions. X equals negative 2 by setting this guy equal to 0. Right, and x equals 4 by setting the other factor equal to 0. Alright, so of course these are not the solution of the inequality, but it's a solution for the equality. Alright, so what we do is use these 2 points, 2 numbers, to place a tick mark on number line. So let's do that. So here, so I'm gonna draw a number line. All right. Then I'm gonna put 2 tick marks at negative 2. So just a label as negative 2, and the other one positive 4. Right. We know that this function right here is exactly equal to 0 if x equals negative 2 or x equals positive 4. So I can probably put 0 there and 0 there. And I'm going to call this function f of x. So this guy right here, maybe I'll use a different color here. This guy, this function, I'm going to call it f of x. Right? So you have, so this is f of x right here. Right? Then what we do is we're going to use a sample point on each interval. So you have an interval here and the middle interval here, and this is an interval there. All right, so we're just going to check. So anything, you can use any number less than negative 2. So I'll try negative 3. All right, so this is a sample number. Right? If you use negative 3, f of x is, let's see, plug in negative 3 here, so that's going to be negative. Right, that's going to be negative here. And if you plug in negative 3 here, so negative 3 minus 4, so it's still negative. Right? So that means that the negative times negative is going to be positive. So we can see that you're going to get a positive value here. Right? Right? The good thing about a continuous function is that on this interval, the sign never changes. So no matter which value you choose from this interval, function is going to be always positive. Right? So let's take a sample point between negative 2 and positive 4. I like 0, so I'm going to try 0 here. All right? Then if you plug in 0, 0 plus 2 is going to be positive. So it's going to be a positive here. Right? Oh, sorry, it's kind of hard to see. So I'm going to erase this first. And erase that first. Right? So you're going to have a positive here. Right? Then if you plug in 0 here, 0 minus 4 is, this is negative. Right? Positive times negative is negative, so we know that on this interval, function f is always negative. All right, after 4, so try any number bigger than 4 would be 5. All right, plugging 5, 5 plus 2 is positive, and 5 minus 4 is also positive, right? Positive times positive is positive, so function f is always positive on that interval. Alright, then we can solve the original inequality because we want this function f to be positive. So we know that it's positive on the interval from infinity to negative infinity to negative 2, and also 4 to positive infinity. So the solution is from negative infinity to negative 3 and positive 4 to positive infinity, right? Because we know that we want the function to be positive, so we want this guy right here, and also this interval right there. So we have an open interval from negative infinity to negative 3. Oh, actually, sorry, it was 2. I miswrote that. So this is actually 2. Negative 2. And positive 4 to positive infinity. So that's the solution for the original inequality. Alright, let's look at the next example. Right, so you have a rational function, we want it to be negative, right? We can actually do pretty much the same thing, right? But the first thing is we're going to look for zeros, right? Just like this one, so we're going to look for zeros. Right, 0 is the same as x-intercepts, right? So we set this whole function equal to 0. Again, I'm going to call this function f of x. Right, so zeros of f is going to be, we set this whole function equal to 0, so x minus 4 over x squared plus 2x, right? Set that equal to 0. Right, but all you have to do is set the numerator equal to 0. Right, then we can just add 4 to both sides, so you have x equals 4. Right, so we found a 0. Right, then we look for places where this function is undefined, so undefined as well, because if the function is undefined, then that value cannot be a solution, right? So in order to find where the function or rational function is undefined, we look for places where the denominator equal to 0. So we set the denominator equal to 0. So x squared plus 2x, and factor out x, and you have x plus 2, and set that equal to 0. Right, so you can see that x is going to be 0 from here, and the negative 2. Right, so function is undefined when x equals 0 or x equals negative 2. Right, then we do the same thing as before. We draw a number line, so this might be a little bit longer. Alright, then use these values to place tick marks. So there's going to be 3 of them. So one here, and one there. Alright, smallest value is negative 2, so it goes here. Next one's 0. Alright, next one's 4. Alright. Alright, so we know that here, I'm going to just indicate when x equals negative 2 and 0, f is undefined. So I'm going to put the d undefined, or some people use nd for not defined. So I'll use ud here. Alright, and at 4, that function is actually equal to 0, so I'll put 0 there. Alright, then we just do the same thing. Pick a sample point, a sample number, so x equals negative 3 there. right? Then try to see if it's positive or negative, right? So plug in, right? So if you put the negative 3 here, numerator would be negative 3 minus 4, so that would be negative, right? If you put 3 here, 3 squared is 9, plus 2 times negative 3, so 9 minus 6, so that's positive, right? Negative divided by positive is negative, so we put the negative sign here, right? Alright, let's try any number between negative 2 and 0, so I'll try negative 1, so x equals negative 1, right? So if you plug in negative 1 on top and bottom, right? So you plug in negative 1, so negative 1 minus 4 is negative, right? Negative 1 squared, which is 1, plus 2 times negative 1, so it's going to be negative, right? So you can see that the negative divided by negative is actually positive, right? How about the between 0 and 4? So I like 1, so I'll plug in, use 1 as a sample number, right? So if you plug in 1 on top, 1 minus 4, so it's still negative, right? 1 squared plus 2 times 1 is definitely positive, right? Negative divided by positive is going to be negative, right? And how about anything bigger than 4? Right, so for example, x equals 5 or something like that. Right, so 5 minus 4 is positive. 5 squared plus 2 times 5 is definitely positive. Right, positive divided by positive is still positive. Alright, so we're looking for places where the function is negative, so you can see that it's going to be negative right here. So on this interval, right, we cannot include negative 2 because function is not defined there, and between 0 and 4, and we are not going to include 0 because it's not defined there. We're not going to include 4 because function is exactly equal to 0, but we want it to be negative, so you have here. So from here to there. Right? So the answer solution for this original inequality is going to be, right, so negative infinity all the way to negative 3, not including 3, right, and between 0 and 4, and not including 0 or 4. So that's the solution of the original inequality. Right? Right. That's it. I hope that this was clear.